Hi, this is János, and I'm continuing the exploration of the classic sensor technology versus modern sensor technology, and my two subjects being the Canon 5D Classic and the Leica M11. As Leica M11, of course, is the modern sensor, and the 5D Classic is the classic sensor camera that I'm comparing. And part of the reason I'm doing it because DxO Mark has measurements of these cameras, and also because I have the 5D Classic myself, so I can relate or expand on the measurements they have and correlate them with the experience I have. In addition, I also have, or I should say had, the 20D, and now sadly it doesn't function anymore, but I've taken lots of photos with it, so I can also share about the measurements they did on it, how they compare with the 5D Classic, and also use this and comparison with other cameras as a benchmark or as a guiding post to explore sensor technologies, because when I see reviews or people talking about cameras or sensor technology, which is really rare, then they just look at random sensors, random comparisons, and they compare, oh, this is better, that's better, but people, that doesn't make any good explanation why one sensor is quote-unquote better than the other, and what is the technology in it that makes it better to the other. And now I'm doing this mini-series here, this being the second part of it, just to expand on it and explore and show what aspects of the technology compare to what kind of feature. And this is a really light-hearted exploration. I don't have a script for it, so probably I'll be just jumping all over the place, but I already did a little bit of preparations for these videos. Like here I have these three cameras. Before I already introduced the 5D Classic and the M11, which will be the comparison of classic versus modern full frame sensor. So those two cameras are full frame sensors, which have, in the mainstream digital world, they have the typically a larger pixel size, but it's only larger pixel when we are comparing similar megapixels as an APS-C sensor or even smaller format sensor. So basically these cameras that you see here are smaller than full frame. So the 20D is an APS-C sensor that's kind of like 2.5 times smaller sensor size than the full frame sensor. So it captures 2.5 times less light. And if you have a same megapixel count APS-C sensor as the same megapixel count full frame, then the individual pixels in the APS-C sensor are 2.5 times smaller. So it catches 2.5 times smaller amount light per pixel than the full frame sensor. And generally that's the basis of why full frame cameras have better low light capability than an APS-C camera. However, what is low light capability? And I'm going to expand a little bit on that for now, because here we have three cameras. The 20D that I had is an APS-C sensor, so 2.5 times smaller than a full frame. And here we have the 700D. It is also APS-C, same size sensor, but it is 18 megapixel. So 20D, 8 megapixel versus 18 megapixel. And the 20D, the 8 megapixel, that was in 2004, so the year is 2004, and the 18 megapixel, the year is 2013, so basically almost like a decade later. So what happened during a decade? And when we so before I continue that train of thought, let's just jump back here. What's in the middle? It's a surprise, because here we have something of the same year, also 2004, just like the 20D, but it's the 1D Mark II. It's also 8 megapixel, same megapixel count as the 20D, but a larger sensor. It's an APS-H sensor, which size is halfway between the APS-C and full frame. So it's 1.5 times bigger than an APS-C and roughly 1.5 times smaller than a full frame sensor. So it's an in-between thing. So Canon started experimenting with APS-H format before they got to full frame. So that preceded the full frame for Canon. And when we look at this, if you the DxO Mark, they have this thing called the Sports Low Light ISO. So that's their benchmark name. So when you read that, it gives you a number. It says a number and ISO. And what does that mean? It means that they have a standard for themselves, which I don't know how they calculate, but they have a measure of calculating what is that hypothetical ISO value where the camera produces a level, a certain quality of image output. And when we cross that threshold, then the image quality is not as good anymore. So virtually, basically in practice and looking at these low light ISO values, it is a hint from DxO Mark that if you use ISO, that ISO or higher, then you will have a high quality picture in the output. And if you go so that's how, what do I mean? Because now I said ISO or higher. So I said it other way around, because it's like 700 ISO or lower, like 400, 200, etc. And basically, like, it means that when it says ISO 721, it means that ISO 640 is the last ISO that you can click on the camera. And if you would click on ISO 800, ISO 800 is not meeting those standards anymore. And same thing here in the 1D Mark II, 1003 ISO. So it means if you set the camera to ISO 1000, you meet that criteria, but ISO 1250 doesn't meet that criteria anymore. And then we have the same thing here with the 700D. It says ISO 681. So it means that ISO 640 meets the criteria and 800 doesn't. So in practicality, essentially both the 20D and the 700D, the last ISO that you can use that meets DxO Mark's criteria for high quality is 640. But in the case of the 700D, it passes it barely, and in the case of the 20D, it passes it more. So basically, when you click on 800 ISO, that's just a little bit beyond the expectations, but quite a bit beyond the expectation for the 700D. And this is actually a lot. So basically, it means that here we have 8 megapixel for these two, the 20D and the 1D Mark II. We have 8 megapixel for each of that, and you get the same perceived high quality with at ISO 1000 with the 1D as you would get at ISO 640 with the 20D. And that's a huge change. So it means that in low light it's going to perform a whole lot better. And these cameras were released the same year, so we are talking about the same generation of sensor technology. Both of them are early sensors of Canon, and the main difference between them is that this one is basically 50% larger pixels. And when you look at the ISO number, the difference between 721 and 1003 is almost exactly 50%. So we are seeing almost an exact translation between the pixel size and the ISO score given the same sensor technology. Now, the 5D Classic has a full frame sensor, and let's look at that. Sadly, this DxO Mark can only compare 3 cameras, not 4, so I have to go to the 5D's page separately, and the 5D's low light measurement is ISO 1368, which is almost double compared to the 20Ds, right? 700 versus roughly 700 versus roughly 1400. So basically we have about twice or 2.5 times the sensor, and we have twice the ISO capability, where the camera, according to DxO Mark, has the same quality image. And how good is this? Because these are just hypothetical measurements. They took photos, they measured it, some computer generated numbers, but how do they translate to real life? Well, I do not have any kind of measurements like that, but I took a bunch of photos with both of these cameras, and my experience is that the image quality that I'm getting with the 20D at ISO 800, the 5D can get that image quality or even better at ISO 1600. So these ISO numbers are right dead on the spot. So it's a really accurate rendering, at least as far as the 20D and 5D Classic go, because what I noticed is that when I look at the ISO 3200 photos of the 5D Classic, they are at least as good as the ISO 1600 photos of the 20D. And so I think that's kind of like a general indication that when you read this ISO number, what is it that you can expect from the camera to do in a low light setting. However, when you read like those things, that there's another feature, that when you look at a camera, let's say you are looking at the 700D, when you look at the specifications, and there in the specifications it will list the ISO, what are the available ISOs, and you see for the 1600, the 20D, it's only 1600 ISO, but actually it's not entirely right, because you can expand even the 20D to 3200 ISO. So this thing is wrong here, because it also goes to 3200 just like the 1D Mark II. However, this 9 years younger generation camera goes to ISO 25,000. So if you just read this number, you would think that this is like 10 times better in low light compared to the 20D. But it isn't. And why it isn't? Let's just go back to the measurements, and let's look at the color sensitivity comparing the 3 cameras, and the 1D Mark II has the best color sensitivity of all. You see, that's the topmost line with the biggest sensor, and then the second is the 20D, and then comes the 700D. So even though the 700D and the 20D have the same sensor size, but the 700D has 2.5 times as many pixels. So the pixel size is really tiny compared to the 20D. It captures less light, and because of that it also has less sensitivity to color than the bigger pixels of the 20D. And when we look at the scores that we looked before, it also translates in the ISO number, which was higher for the 20D than the 700D. It wasn't much higher, but it was still a little bit higher. Now, this is where it all ends, at ISO 3200, right, for the 20D and the 1D Mark II. But for the 700D, which is a decade younger camera, it goes down to ISO 25,000. But as you see, what you see here is that the curve dips very, very low. What does this mean? So what this figure means is that here on the y-axis we see the number of bits of color information available, which is around 22 bits for starters. Then at ISO 100 for all three of them, it's like 21.7 to 22.3. So just like half a bit difference between the three cameras. Not that much. They are relatively close, but if you look at the photos at ISO 100, the 1D Mark II has noticeably better color. So even that half a bit difference, although seems very tiny on paper, but in reality it will show up as nicer, noticeably nicer colors. And as we go higher with the ISOs, we will have less and less color information. And now here you see a dotted green line here, a dotted yellow line, and a dotted red line. And basically they put a dotted green line. This is around 20 bits. So it means that if per DxO Marks standards, you need at least 20 bits or more. And when you have about this much information, then you will have high color density. You will have beautiful colors in your image, a lot of information. And this area, so where it crosses the green line, so when we are on top of that, then you have very high quality picture, and when you dip below that, that's when you get to mediocre picture quality universe. So when you want high quality photographs and you want to have measurements to help you which ISO values can you use with your camera, then you can look up DxO Mark and see which are the ISO scores above the green line for the measurements at the color sensitivity range. And the ones that are above the dotted line, here in this case, actually almost all of the cases, we have 100 ISO, 200 ISO, and let me see, hard to say, but for the 20D and the 1D Mark II, 400 ISO is still there, but for the more modern camera, the 700D, 400 ISO falls off from the high color density spectrum. So this is where you will noticeably find that the camera, that the pixel size is becoming your enemy. And this is not just true for this specific Canon camera. It doesn't mean that, oh, Canon is not as good as Sony or Nikon or whatever. No, this is just the general laws of physics, that when you shrink the pixel size, the effects will be noticeable the higher you go up with your ISO setting, because you see, even with those much smaller pixels than the other two cameras, at ISO 100 there's very little difference between these cameras, right? Not much. You would think you would have more difference, but not much, very tiny. And when you go to even more modern cameras, like now the 2020s, then even at 100 ISO, cameras that have super high density, like Sony modern cameras, they still have higher color bits, color sensitivity than these cameras did. And however, for all of them, it's true that once you start going higher with the ISO, the sensitivity drops. And in each case, like a camera from 2004 at ISO 100 has way better color sensitivity than any, even the best modern cameras at ISO 3200. An ISO 100 modern old camera will eat any current camera with high ISO setting at color sensitivity. And that's just the laws of physics, because everything works optimally with low ISO setting. And now, as you see, when we dip below the green level, we are in mediocre level, and when we dip below the yellow line, and the yellow line is around 17 bits, that is poor image quality. So like 14 bits to 17 bits is poor image quality. And when you drop below the red line, that is like security camera footage. So basically, with the modern cameras where you see these extremely high ISOs, what we are getting is the ability to use your camera as a security camera, which is optimized to give information from very low light environments, but you are not getting color information there. You are getting very poor quality, very noisy. So you have just basically, it doesn't mean that at these high ISOs your camera is going to give you a 10-bit file. No, it's still going to give you a file that has the RGB values of 24 bits, but out of those 24 bits, only 10 bits are going to contain useful information, and 14 bits will be noise. And this is the reason why when you go higher with the ISO value, the larger the file size gets, because more of the bits will be occupied by noise. So in every single case, all of them, you will get the same amount of bits output by the sensor, but as these drop, as you drop down, more and more of the bits will be containing noise instead of actual image data, actual capture data. And so I think that's part of the mystery of the high ISO. So what is happening today? Why there are some cameras like 10 years ago, the 700D, let's just go back here, the 700D 20 years ago at ISO 2500 captured photos like a security camera. And today, now we have like the Canon R3. This also can do 25,000 ISO, but at 25,000 ISO, it still can deliver just spectacular image quality. And that's for several reasons. One of them is that it has giant pixels compared to the 700D, because it's only a 24 megapixel camera, but it's a stacked sensor, so effectively the pixel size are the same as if it was an 8 megapixel sensor. So those are the sizes of the pixels, and the three colors are stacked behind each other. And so it has giant pixels. So compared to the 700D, I think I haven't done any calculations yet, but approximately it would be maybe like 10 times, about 10 times the size each pixel that collects light, 10 times more light collected per pixel compared to the 700D. And that does reflect in, let's just go full signal to noise ratio, logarithmic. It takes a little while to load the data. Okay, it loaded the data, and let's see what we are getting here. Is that, well, you see that it's really compromised compared to the high ISO value, but actually I'm not showing you the right color sensitivity. We were looking at the color sensitivity figures. So, okay. So the color sensitivity, it crosses the red line at ISO. So the camera setting is ISO 12800. So even at ISO 12800, this camera takes the same perceived picture quality as the 20D takes at ISO 6400. But I think I would not agree on that, because I think the R3 takes at ISO 26000 takes a much better picture than the other at ISO for 6000. But so I think here it's not really identical, but I think that they just have a higher expectation. I don't know. So sometimes the calculations are really accurate, but I think in this case it is not as good as it was in the previous cases, and here it does not reflect as well how exceptionally good the R3 is at low light. It's just incredible. So even at ISO 12800 is just, it takes absolutely phenomenal pictures, and here the DxO Mark doesn't really capture how good this camera is in real life. However, with these primitive cameras and their comparisons, the comparison is actually pretty accurate, I would say. And it's just a warning that anything you see below the red line is kind of like, especially in these older cameras, security camera footage, like in the new cameras like the R3, eventually this region is much more useful than this graph would suggest, because these modern sensors do a lot of noise processing. And when you go back to these more older cameras, the older we go back, the less processing there is. And part of it is that at first look, these pictures taken by these cameras are more noisy and not as good as the ones taken by a modern mirrorless camera. But what is behind that is that these cameras, when you have even like a raw output, it's not what comes out of the sensor directly. It goes through internal image processing and then it gets recorded as raw. So it's a pre-processed image. So every single modern camera does very heavy pre-processing on the raw files, and as we go higher in the ISO values, the more extreme this processing gets. So when we are at an ISO 100, there's not much processing applied to the image, but as we go higher with the ISOs, the processing gets absolutely drastic. And when you go back to these earlier cameras, like the 20D or the 5D or the 1D Mark II, there's next to no processing. So what the raw file is what the sensor measured. It's in the file, you download it, and if it doesn't look as impressive as a same ISO shot taken with a modern mirrorless camera, the reason behind the difference between how they look like is that the classic version, the old camera, it did not have any internal signal processing done to the image. However, you can do your signal processing using Photoshop, using DPP4 if you have Canon, or other software that can do processing. Nowadays you can use like Topaz AI to do quite kind of drastic alterations to the image, and but you can do that, and you can make a photo that was taken by an old camera look like a photo taken by a new camera. Just process the heck out of it, and then it will look just as photoshopped as a raw file looks like from a modern mirrorless camera. Now there's the caveat that if you want the modern look, you have to put in more work on your old photos to make it look like a new photo. But if you have the photo taken by a modern camera, you cannot make it look like it was taken with an old camera, because you cannot unprocess the photo. All of them come pre-processed, so it's kind of like baked. So if you have a well done steak, you cannot make it rare or medium rare. But if you have a rare steak, if you cook it longer, you can make it medium or well done. and the Canon 20D 5D, that gives you a rare steak, and then with Photoshop or other programs you can fully cook it to well done or charred or crispy. So I think that that's it for now, for the second part of this little comparison of the ISO values and what cameras put out, and that's it for today. I hope it was helpful, and you have enjoyed it as much as I did making this video. Bye team, bye bye.